We can't copy this. German engineers stunned by Sherman's hidden 90-second advantage, the captured M4. Sherman sat inert, its tracks scarred, its hull pockmarked by shrapnel. German engineers, meticulous and proud, circled the American tank, their initial assessment dismissive. Crude armor, an unsophisticated gun, typical American mass production, they thought. But as they delved deeper, a hidden secret began to emerge. A design philosophy so alien, so pragmatic, it would leave them utterly stunned. A revolutionary advantage, born from Detroit's assembly lines, capable of returning a crippled tank to the fight in a mere 90 seconds. They would call it impossible, as the storm clouds of World War II gathered over Europe. America, still reeling from the Great Depression, watched with a growing sense of inevitability. When the nation finally plunged into the global conflict, it faced an unprecedented challenge, transforming its vast industrial might into a war machine capable of confronting the formidable Axis powers. Unlike the European nations, whose military doctrines and industrial capacities had been honed over centuries of conflict, the United States approached warfare with a distinctly American philosophy, one rooted in mass production, efficiency, and a pragmatic can-do spirit forged in the factories of Detroit. This ethos would profoundly shape the design of its primary battle tank, the M4 Sherman, setting it on a collision course with the German engineering dogma of individual perfection. In the early days of the war, German tank design, exemplified by the Panzer III and I-4, and later the Panther and Tiger, prioritized individual combat prowess. Each component was often custom-built, meticulously crafted for optimal performance, regardless of the complexity or time required for its manufacture or repair. This approach yielded powerful, technologically advanced machines, but it also created a logistical nightmare. Every repair, every maintenance task became an intricate, time-consuming operation, often requiring specialized tools, highly trained technicians, and even factory-level support to rectify even minor issues. A damaged engine in a German tank could mean days, if not weeks, of downtime, effectively removing a vital asset from the battlefield. Across the Atlantic, American strategists and engineers understood that while individual tank superiority was desirable, it was ultimately battlefield availability and sheer numbers that would win the war. The United States needed a tank that could be produced in unprecedented quantities, quickly and, crucially, one that could be maintained and repaired with equal speed and simplicity in the brutal, chaotic environment of the front lines. The design brief for the M4 Sherman was not just about firepower or armor. It was about reliability, ease of manufacture, and above all, rapid field serviceability. This was the birth of a revolutionary concept, the modular power pack. The idea was radical. Instead of an engine integrated deeply into the tank's structure, requiring extensive disassembly for repair, the Sherman's designers envisioned a self-contained unit, engine, transmission, and cooling system that could be quickly disconnected and replaced as a single module. This was Detroit, thinking applied to military hardware. If a component failed, you didn't fix it in situ. You swapped it out for a new one, sending the faulty unit back to a specialized depot for repair. This approach was a direct inheritance from the automotive industry, where assembly lines thrived on interchangeable parts and efficient component replacement. Initial skepticism within military circles was inevitable. Traditionalists argued that such a design would compromise structural integrity or add unnecessary weight. But the proponents of modularity, driven by the urgent demands of war, pressed forward. They understood that a tank sitting idle in a repair yard, no matter how powerful, was useless. A tank that could be returned to the fight in minutes, even if it wasn't the most heavily armored or powerfully armed, represented a far greater strategic asset. The engineering teams, fueled by coffee and patriotism, worked tirelessly, sketching designs, fabricating prototypes and testing concepts. They faced challenges in standardizing connections, ensuring robust yet quick-release mechanisms, and designing a power unit that was compact enough to be easily handled. Yet, the American can-do spirit prevailed. They believed in their ability to innovate, to find practical solutions to complex problems, and to leverage their industrial might in ways no other nation could. The goal was clear: create a tank that could be built by the thousands and fixed by the dozens, a true workhorse for the Allied war effort. This foundational design philosophy, born from the urgent necessity of war and the ingrained pragmatism of American industry, would soon manifest in a capability that would utterly baffle their German adversaries. The stage was set for the Sherman's hidden advantage to emerge, an advantage that would redefine battlefield logistics and operational tempo, proving that sometimes simplicity and speed trumped brute force and intricate perfection. The modular power pack was not just an engineering feature, it was a declaration of American industrial might and ingenuity, a testament to a nation's ability to adapt and overcome. The M4 Sherman's modular power pack was a marvel of pragmatic engineering, a direct descendant of the American automotive industry's relentless pursuit of efficiency. Unlike the intricate, often bespoke engine installations found in German tanks, the Sherman's heart was designed as a self-contained unit. This meant the engine, its transmission, and even its cooling system were integrated into a single, easily detachable assembly. The genius lay in its simplicity. Quick disconnect fuel lines, electrical harnesses, and drive shaft couplings allowed the entire power unit to be unbolted and lifted out of the tank's rear compartment. This wasn't just a theoretical concept. It was a meticulously engineered system, refined through countless hours of design and testing, ensuring that every connection was robust enough for combat, yet simple enough for rapid field manipulation. The training of American tank crews, and more importantly, their dedicated maintenance teams, revolved around this revolutionary capability. Mechanics, many of whom had previously worked on cars and trucks, were taught to view the power pack as a giant interchangeable component. Specialized recovery vehicles, equipped with cranes, became indispensable tools, not just for towing disabled tanks, but for facilitating these rapid engine swaps. Drills were conducted repeatedly, under simulated combat conditions, until the process became second nature. The goal was not just to replace an engine, but to do it under pressure, quickly and efficiently, minimizing the tank's downtime. The results were astonishing. In field tests, a well-drilled crew could indeed perform a complete power pack replacement in an almost unbelievable 90 seconds. This wasn't the time to repair the engine, but to swap a damaged or malfunctioning unit for a fully operational one. The faulty power pack would then be sent to a rear echelon maintenance depot for thorough repair, while the tank, now with a fresh heart, was immediately returned to the front lines. This capability was a game-changer, a stark contrast to the laborious and time-consuming procedures required for German tanks. Consider the formidable German Panther, or Tiger. Their Maybach HL-230 engines, while powerful and meticulously crafted, were deeply integrated into the tank's chassis. A major engine repair or replacement on these behemoths was an undertaking of monumental proportions. It often required specialized heavy-lift cranes, not just recovery vehicles, and a team of highly skilled mechanics working for days, sometimes even weeks. The entire engine deck had to be removed, numerous complex connections painstakingly disconnected, and the massive engine carefully extracted. Then, the reverse process for installation. This wasn't a field repair, it was a factory-level operation, often necessitating the tank's removal from the front lines and transport to a dedicated repair facility far behind the combat zone. The logistical nightmare this created for the Wehrmacht was immense. Every Panther or Tiger that suffered an engine failure or required significant maintenance represented a critical loss of combat power for an extended period. Spare parts were often scarce, and the specialized tools and expertise were not always readily available at the front. This meant that even a minor mechanical issue could render a German tank effectively useless for a crucial phase of a battle or even an entire campaign. The German emphasis on individual tank superiority while yielding impressive machines inadvertently created a bottleneck in their operational readiness. The American approach, born from the pragmatic necessity of mass warfare, turned this paradigm on its head. The Sherman might not have been as heavily armored or as powerfully armed as its German counterparts, but its ability to remain in the fight, to be quickly repaired and redeployed, gave it an unparalleled strategic advantage. This rapid turnaround capability meant that Allied forces could sustain offensives, absorb losses, and maintain a higher operational tempo than their adversaries. The power pack revolution was more than just an engineering feat. It was a testament to a different philosophy of war, one that valued continuous presence and adaptability over individual, albeit formidable, perfection. The Germans, with their rigid adherence to traditional engineering principles, were about to discover the true cost of their perfectionism when confronted with this distinctly American ingenuity. The battlefield was about to reveal that the fastest tank wasn't necessarily the one with the biggest engine, but the one that spent the most time fighting. The M4 Sherman, often derided by some as a death trap or Ronson lighter due to its perceived vulnerabilities, proved its true worth not through individual duels with superior German armor, but through its sheer relentless availability on the battlefield. While a Panther or Tiger might boast thicker armor and a more potent gun, its impact was severely limited if it spent more time in a repair depot than on the front lines. The Sherman, by contrast, was the epitome of a workhorse. Its modular design meant that even after sustaining significant damage, particularly to its engine or transmission, it could be back in action with astonishing speed. This rapid turnaround capability became the Sherman's hidden superpower, a force multiplier that profoundly influenced the operational tempo of Allied campaigns. Countless anecdotes from the front lines underscored this advantage. American tank crews, knowing that a disabled engine didn't necessarily mean the end of their fight, fought with a renewed sense of confidence. They witnessed firsthand how a Sherman, knocked out of commission by a mechanical failure or even minor battle damage to its powertrain, could be towed to a relatively safe area, have its engine swapped out by a dedicated maintenance crew in minutes, and then return to the fray within the hour. This was a stark contrast to the German experience, where a similar incident would often mean the tank was out of action for days, if not permanently lost, due to the difficulty of recovery and repair. The psychological boost for Allied troops was immense. They knew their equipment was resilient and their support system efficient. For German commanders, this phenomenon was a source of growing frustration and bewilderment. They would report Shermans destroyed, only to see them reappear on the battlefield hours later, seemingly resurrected. This constant presence of American armor, even after engagements, chipped away at German morale and complicated their tactical assessments. They couldn't understand how the Americans maintained such a high operational tempo, especially given the logistical challenges of a rapidly advancing front. The true revelation came when German engineers finally had the opportunity to meticulously examine captured M4 Shermans. Their initial assessments were often dismissive. They noted the Sherman's relatively thin armor, its less powerful 75mm gun compared to their 7.5 cm KWK-42 or 8.8 cm KWK-36, and its somewhat boxy, utilitarian design. To their eyes, accustomed to the sleek, powerful lines and intricate internal mechanisms of their own tanks, the Sherman appeared crude, a product of mass production rather than precision engineering. They saw it as an inferior machine, a testament to American industrial quantity over German quality. Then came the moment of discovery. As they began to dismantle a captured Sherman, they encountered the modular power pack. The ease with which the entire engine and transmission unit could be disconnected and removed left them utterly stunned. They traced the quick-release mechanisms, the standardized mounts, the self-contained nature of the assembly. Disbelief turned to a grudging, almost bewildered admiration. "We can't copy this," one engineer reportedly remarked, his voice tinged with a mix of awe and frustration. They understood the concept, but they couldn't reconcile it with their own deeply ingrained engineering philosophy. The German approach prioritized maximum performance and protection for each individual tank, often at the expense of manufacturing complexity and field serviceability. Their tanks were designed to be formidable fighting machines, but not necessarily easily repairable ones. The idea of designing a tank around the principle of rapid component replacement, rather than optimizing every single internal system for peak performance, was alien to their perfectionist mindset. They saw the Sherman's modularity not as an ingenious solution to a battlefield problem, but as a compromise, a shortcut. Yet, they couldn't deny its effectiveness. The cultural clash was profound. German doctrinal rigidity and engineering purism confronted by American pragmatic innovation and mass production efficiency. The Sherman's hidden advantage was not in its ability to destroy more German tanks, but in its ability to be there to fight day after day, battle after battle, a relentless tide that German engineering, for all its brilliance, simply could not stem. The true genius of the M4 Sherman lay not in its individual specifications, but in its collective impact. While German tanks like the Panther and Tiger were formidable adversaries in a head-to-head engagement, their operational readiness rates told a different story. It was estimated that a significant percentage of German heavy tanks were often out of commission due to mechanical failures or battle damage, requiring extensive, time-consuming repairs. These powerful machines, designed for perfection, spent an inordinate amount of time in rear echelon workshops, awaiting specialized parts or the skilled technicians required to perform their intricate maintenance. The Sherman, by contrast, consistently boasted high availability rates, often exceeding 70–80% on the front lines. This statistical disparity was the unseen advantage, the silent force that tipped the scales in favor of the Allies. This cumulative effect on the war effort was profound. The ability to quickly return damaged Shermans to the fight meant that Allied forces could maintain relentless pressure on the enemy. They could absorb losses, knowing that many of their knocked-out tanks would soon be operational again. This sustained momentum was crucial for the rapid advances across France after D-Day, the relentless push through the Siegfried Line, and the final drive into Germany. While individual German tanks might have been superior in a static defense, they simply could not match the sheer, continuous presence of Allied armor. The Sherman's rapid repair capability allowed for faster advances, sustained offensives, and a higher overall operational tempo that the German war machine, with its logistical bottlenecks and repair complexities, simply could not counter. The German engineers, having dissected the Sherman and understood its modular heart, were left with a stark realization. This wasn't just a design choice, it was a fundamental difference in industrial and military philosophy. Their own doctrine emphasized quality over quantity, individual prowess over collective resilience. They had built magnificent machines, but they had inadvertently designed them for a different kind of war, one where time and resources for repair were abundant. A luxury that the rapidly deteriorating German war economy could no longer afford. The American approach, born from the assembly lines of Detroit, was a testament to a different kind of strength, the power of standardization, interchangeability, and pragmatic efficiency. The hidden advantage of the Sherman was not its firepower or its armor, but its staying power, its ability to endure and return to the fight. It was the embodiment of the American can-do spirit, a reflection of a nation that valued practical solutions and mass production. This philosophy allowed the Allies to field vast numbers of tanks, and more importantly, to keep those tanks fighting. The German engineers, initially dismissive, eventually developed a grudging respect for this distinctly American ingenuity. They understood that while their tanks might have been technically superior in some aspects, the Sherman represented a more effective weapon for the realities of total war. It was a weapon designed not just to fight, but to keep fighting. The legacy of the Sherman's modular design extended far beyond World War II. It influenced subsequent tank designs, emphasizing ease of maintenance and component interchangeability. The principles of modularity, rapid replacement, and standardized components became cornerstones of modern military engineering and indeed of many civilian industries. The lesson learned from the Sherman was clear. In the crucible of war, operational availability and logistical efficiency could be just as, if not more critical, than raw power or individual technological superiority. The German engineers, in their disbelief and inability to replicate the Sherman's 90-second advantage, inadvertently acknowledged the profound impact of this American innovation. It was a testament to a nation's ability to turn its industrial might and pragmatic spirit into an unstoppable force, proving that sometimes the most revolutionary ideas are the simplest, and the most effective weapons are those that never stop fighting. The story of the Sherman's hidden advantage is a powerful reminder of American ingenuity. It's a testament to how pragmatic thinking, born from our industrial heartland, can overcome seemingly insurmountable challenges. This legacy of innovation, of finding smart solutions to complex problems, continues to define us. Let's remember the spirit that built these machines and continues to drive progress, ensuring America remains at the forefront of innovation.